Good morning, good afternoon, good evening, everyone, based on your location. It's thank you everyone for joining this session, being a Sunday. So today we will keep it very simple, and the topic for discussion for today is big data architecture and the best practices on AWS. So as far as agenda is concerned, so I will tell about myself. Then we will go through what are the big data challenges, the architecture principle behind big data, how to simplify big data processing, what all technology we should use because the number of technologies available in the market are huge. So getting the best solution for our problem is very must. And then we will go through a reference architecture. As Priyanka mentioned in the introductory call, I'm working as a data engineer with Amazon currently. So I have 10 plus of experience in data engineering with deep focus on data warehousing, data modeling, data governance, data management, data warehousing, and all those stuff related to data. So I have worked on multiple cloud technologies. I have worked on Amazon Web Services. I have worked on Microsoft Azure services, and also I've created a number of pipelines that could cater to organization need. The basic criteria is getting good quality of data, transforming them, making it enriched so that it can be used for analytics and data science purposes. So why does this big data comes into picture? In the last 10 years, we have seen a massive explosion of data. Data is not increasing in a linear way, but in an exponential manner. We are getting data from social media, Facebook, Twitter. We are getting data from our DBMS system. We are getting data from flat file system. We have mobile application. We have Internet of Things, IoT devices, which are generating massive data every single second. So every organization wants to utilize that data to become a data-driven organization. Data is growing. We are getting new sources of data. We are getting diverse nature of data. Earlier, we used to get only data in a relational format like tables and columns and rows. But now we are getting data in all the format. We are getting images, we are getting pictures, we are getting video files, we are getting logs file, audio files. There is no dearth of data available in the market. Similarly, data is getting produced by multiple source system. Similarly, data is being absorbed by multiple system. Everyone is using data, but how to make that data more valuable is a need of the hour. We have technologies, we have tools that can analyze that data, that can use that data, but still we are not able to drive values from it. Reason being, we do not have technologies in place so that that can give values to us. If we talk about technologies, we have everywhere. We have all the major service provider providing technology. But as a customer, as a user, as an organization, I need to explore which technology is good for my use case and how I can use that so that to get more values from the data. In today's world, all the organizations who are data driven are the one who are excelling it because data gives always a right picture. Hence, it's very important to understand how we can make our big data architecture in AWS. Before going to the technology and the services available, let's see how this big data evolved. Earlier, we used to have data and we used to do batch processing. Batch processing is nothing but, for example, whatever data is coming, we are doing in once a week, once a day, or once a hour. So, like for example, we are doing a batch processing of one day. So all the data that had been collected yesterday will be processed today. But this was 10, 15 years ago. Then comes stream processing. As soon as data is coming, we will process it. Just imagine your mobile network is not recharged. You just click on one button, it got recharged in the same way. So this is stream processing. As soon as data is produced, you will get the data in the output format. In the current world, whatever activity is happening on Twitter, we have application for stream processing. As soon as there's a new tweet in the Twitter world about any particular political, geo, or sports, or culture, or literature, any event, it get it get processed, and people start creating more information out of it. That is stream processing. Every single second, you are getting output of the data. Now we have moved to another format of big data evolution that is artificial intelligence. Now we are not just processing the data and getting the output, but we are providing recommendation also. Can you imagine 5 years ago you search for any mobile on your YouTube or any on Google, but at the same time you get recommendation for that particular mobile on other application like Amazon, Flipkart, or any other eBay for buying it. So this is artificial intelligence. As soon as data is getting processed, it is giving recommendation also. It is giving production also. Like this person has searched for this particular mobile category. Let's recommend him to use it. So that as soon as you open the Facebook app, you start seeing recommendation about the same product which you search in Google 2 seconds ago. So that has been a evolution in big data world. From batch processing to stream processing, now we have moved to artificial intelligence, where we are giving recommendation to a user through data processing. And how does cloud service evolve in this particular big data evaluation? When cloud was launched by AWS in 2006, they used to provide virtual machine. So you have virtual machine in AWS, virtual machine in Microsoft Azure. So there you can go, you can install software, install your database, write your code, and start running the services. You don't have to focus upon creating the machine for your or organization. But from that onwards, we have moved to managed service. Now AWS and other cloud providers are providing you managed service instances where you don't have to install even a software or database or deployment or anything. You just go there, you have to use their software, whatever providing. Like for example, for database, you can go for Amazon RDS. It's a completely managed service. You have to just use their database RDS. You create a table, insert your data, and start using it. You don't have to worry about the update on database, quick fix on the database, how to start the database, how to end the database. Everything is managed service. Now we have moved to another cloud service evolution, that is serverless. Now in 2022, people are talking about serverless. No one wants to even go into managed service. Reason being, AWS or Amazon or Azure have provided serverless services so that you don't have even have to talk about servers also. You don't have to restart your server. You don't have to up down your server. You don't have to create your own server. Everything will be done by cloud service. You have to just write your code, just write your logic, and start using the services. So as a customer, as an organization, it's very efficient for me. I don't have to invest money in creating the team that will handle the server creation, server management, or I will don't have to work for data center. Everything will be done by cloud services. I just have to write my logic, my code that would drive information for me. So this serverless evolution in cloud service plus artificial intelligence and big data has created changed the landscape of the data world in today's world. Everyone is focused on using serverless technology so that they don't have to invest time, money, plus people on those activities which can be handled by cloud itself. Now come what are the big data challenges. Every organization want to be data driven. Every organization want to have big data processing in their system. But why are they stuck? Why it's not that it's not easy to use, or maybe it's applicable to everyone, like one fits solve every equation. It's not. So everyone is looking for, is there any reference architecture which they can use? What tool should I use? There are a number of tools available in the market, and the organization and the company and the people are not able to clear which tool should I use, because they are not able to do comparative study, or they don't have manpower to do comparative analysis, or they don't know which technology I have to use, or which technology will suits my purpose, and how we can use it, and why should I use it. So these are all the challenges which is currently available for organization and people to understand to solve their big data problem. It's very easy to say that tools are available in the market, just use it. If tools are available in the market and you can just use it and get the value, it would be very simple. But it's not so simple, because reason being, we have to identify which tool is good for my organization, which technology will suit my use case. For example, if company A is using Microsoft's Azure services, particular X service, so will that X service suit my purpose also? Maybe or may not be. Similarly, if they have failed in particular technology Y, will I also fail in technology Y? Maybe, may not be. So you have to do POC on that. You have to do proof of concept on that. You have to evaluate the technology. You have to evaluate your use case and see how both the things work together. The major architecture principle behind any big data processing is that you should always decouple storage from compute. When I say decouple, what does decouple mean? Decouple means that your storage and your processing power should be separated. Just imagine 10-15 years ago, we never had this Spark processing in picture for us. So everything used to be there in total system, storage and compute, we used to do together. But just imagine that 5 years later down the line, any new technology comes, then it's very difficult to adapt to that technology if that coupling is not there. If we have decoupled system, like storage is different and compute is different, we can easily replace the compute part with the new technology while the storage part remains the same. So if you see the life cycle of a data, then comes storage, then process, then again storage, then analyze, then answer. So this storage, process, storage, analyze is a cycle. It will keep on going on. You will store data, you will process it, then you will again analyze it, you will again store it. So it's better you separate the storage from the compute. The storage part should be separate, and the process or the analyze, the compute part should be separate. It will make a system more robust. for in future, if you want to replace your storage with other technology, you can easily do it. You don't have to depend on the process or the compute power. Similarly, if compute power changes in after 5 years, we have some other technologies, maybe which is far efficient than Spark. Then we can easily replace our compute power with that technology, and the storage will remain the same. So it's very efficient and very essential to build a decoupled system. Decouple means these are not interlinked to each other. The second principle is use the right tool for the job. As I mentioned in the previous slide, that if technology X works for company A, it doesn't mean that technology X will work for company B also. So we have to evaluate it, whether this particular tool, this particular technology is good for us. We have to identify on the basis of data structure, the amount of the quality or the format of data which we are receiving. For example, company A has only relational database like rows and column, but we don't have rows and column. We have a JSON type of format where we don't have a fixed schema. For that purpose, technology A suits the purpose for fixed rows and column, but will not serve our purpose because we don't have a fixed schema. Similarly, what is the latency of the technology? What is the throughput of the technology? Amazon app, which where you search for example, I want to search a new mobile, you get result in milliseconds. For that, latency is different, but the technology or tool which is used for data warehousing, their latency is different. We know that we will get the answer in maybe 2 seconds or 5 seconds. So their latency is different. Similarly, throughput, the access pattern, how that particular data is being accessed by the end user. If it is used once in a week or once in a month or once in a day, then its access pattern is different. But for transaction system, it is concurrently accessed. One in 1 second, it can be accessed by 10,000 users. So you have to choose the right tool for that. The third is how to leverage, manage, and serverless services. Gone are the days where we should invest our time, money, and people in maintaining data centers, maintaining servers. You don't have to do all those stuff. Let the cloud do those stuff, managing your servers, managing your database, managing your software, whatever updates is required, let them handle it. You just focus on the main logic on it, in the code part of it, how you can drive intelligence from your data. So there are elastic available, scalable system available, which are reliable, which are secure. No low admin means that you don't have to invest your time in doing admin work, like for example, there is update in Spark language, or maybe there is update in database Oracle. So you don't have to invest your time in updating the or upgrading your hardware or software. That thing can be handled by cloud. You just focus on the main part of the logic creation and getting value from your data. Another principle is that you should always have your immutable logs data. That means that immutable means bring all the data that is possible in your system. Don't say that if I get this amount of data, my storage will increase. Storage is very cheap in current world. Don't go for just storage cost. Storage is very cheap. Bring all the data over here. Maybe you don't know what's the question the analyst will be asking from data science model. So have all the data. Whenever it's required, you can use that data in your data science modeling and in analytics. But don't work on system where you can, okay, let's bring this amount of data. Let's keep that data out of our system. Bring all the data, and that data can be used anytime. Because you never know what's the question would be asked by analyst or what question you are expecting. For example, you are just focusing on sales data, but maybe sales data is linked to marketing data. If marketing of a product is done in the right way, the sales increases, but you don't have marketing data. So you cannot create your analytics, or you cannot create your future promotions or future views of how you can increase the sales of that particular product. So hence the reason is always have all the data in your system. Use maybe today, maybe tomorrow, maybe after that, but bring all the data. Another principle is that be cost conscious. We always believe that big data equal to big cost. It's not those. If you choose wisely, if you evaluate your options wisely, you will always have an option to cut down your cost. It's not that if you're using cloud services for big data applications, so you have to give a huge amount or huge chunk of money from your pocket. No, it's not that. If you evaluate wisely, if you see, okay, these are the options available, and this option is cheaper to me in comparison to X option, then go for that option. So it's not like you have to always give a huge chunk of money for big data application. Be cost conscious, then only you can able to create more robust system, more scalable system, and system that will definitely give you values. And last and most important point in current world is AI ML enable your application. Whatever data you are getting, whatever data you are getting as output, please put AI ML model over it, because it will give you more indication, it will give you more prediction, it will give you more recommendation, and that will help you in creating data-driven policies for your organization. So these are 6 principles which are very important for big data processing in cloud. Build decoupled system, use the right tool for the job, leverage manage and serverless architectures, use log-centric design pattern, be cost conscious, and sixth, AI ML enable your applications. Now comes to that what all component are available or what all component makes big data processing very tough. And to simplify it, I've created this particular slide. So from left side, we are getting data, and from the right side, we are getting answer. In middle are the 4 different component. One is collect, how you collect your data. Second is how you store your data. Third is how you process your data. And fourth is the consumer part. And time to answer increases with the level of the stage. Like for example, at the collect level, time to answer is very far. Reason being, you don't have any information with you. But when it comes to the consume part, the data is so much driven that your answer is very quickly. So time to answer is the latency between each to the level of the steps. Collect step, store step, process, and consume. So these are the 4 stages of the big data processing, and all the services are available for these steps only. So you have to evaluate which service to choose. Now, before going into the services available for all those 4 steps, store, process, analyze, let's focus on the data characteristics. How hot, warm, cold is my data? Or what's the temperature of my data? So by temperature of data means how frequent my data is being used. So in your transaction system, whenever you purchase any product from an e-commerce website, so that is hot data because it has been used very frequently. You have to just look for the value of the product, you have to buy it, you have to do the payment. So that's the hot data. Warm data is something which is kept in your data warehouse, which may be not used very frequently, which is used on a daily basis, but not on the hourly or the second basis. Cold data is something which you have archived your data, which you have placed in some archival system, which is not used as frequent as warm, but may can be used in future purpose for data science project, for data science model, and can be used and can be evaluated and can be justifiable for future. So that is called cold data. So we have hot data. The volume is very low, like megabyte to gigabyte. Warm data is more than hot, like gigabyte to TB. Whereas cold is it's like archival system. You have 10, 15 years of data in a petabyte or exabyte range. As we talk about the latency, the hot data is something which is required very fast. Even millisecond in today's world is very long number. We even want data in nanosecond as of now because you just imagine you are working or e-commerce application. Your customer opens the e-commerce application, he search for mobile, and it giving result in 2 milliseconds. So it's a very bad impression. How can I reduce my latency? How can I give my result even in before 1 millisecond? It's what the required of the hot data. Whereas warm data is concerned, it is millisecond to seconds. And when it comes to cold data, it's used very infrequently. So it's used maybe once a week or once in a month. So it can be minutes, it can be hours. So latency does not role any play in cold data. Now comes to the cost. Cost of hot data is very high. Reason being, you have to make it very fast. For that, you have to bear the cost of it. That's why it's in dollars. For warm data like data warehousing, you can keep your data in a system which is less accessible, maybe gives result in not a millisecond, but in seconds or minutes. So the cost is comparatively less in compared to hot data. Whereas cold data cost is very less because you are storing data in a file system or maybe in disk. So they are not very frequently used. Hence, you can keep it there. Even if they take times to get retrieved, then we don't have any issue. So that's a characteristic of data hot, warm, and cold. And on the basis of this only, we can choose which service to evaluate and which service we should use for our application so that we don't have to bear the latency issue. So like for example, hot data latency is the least. So we want data in 1 millisecond. So for that, we have to bear the cost. Similarly, for cold data, we know that even if it takes 2 hours to get data from file system or maybe archival system, hard disk or something, we have no issues because it's not a like transaction system. It's a very archival system. Even if it's giving data in 2 hours, then it's fine because we are just searching the data. But for hot data, we want latency has to be very minimized, minimum to minimum. Hence, it's there that we have to be very high in cost. Now comes that we have studied the 3 different types of data available, like cold, hot, and warm. But how we can select the storage for it? On the collection side, we can have web application, we have a mobile application, we have data centers, we have logging devices, we have device sensor, we have IoT platform, which are already available. Now, what types of records, what types of data is produced through these defines which type of storage we should use. Like in the first part, in the application part, like web application, mobile application, they produce records. People who do transaction on their system, they bought a mobile, they bought a watch from their system. These are the transaction record, or maybe someone going to CRM system and going doing their entries over there. So these are transaction system. The second type is logging system. In logging system, we always get the record in the form of files. So it could be media files, it could be log files, it could be images, audio file, video files. So all these are file system. And third is the streaming data, which we get from the IoT platform. Just imagine you have a sensor device attached to a machine or to a locking door. So it will keep on producing stream of data. For that, we require different type of storage. So that goes into the data stream or the event storage. So now we have three different types of data available to us. One is transactional data, one is file data, and the third is events data or the streaming data. Now, whatever application we have, so we have to identify which storage will be good for us. So let's talk about file storage, which is a file storage service available in AWS, which we can use for our application. So we can use Amazon S3 as a persistent file storage. S3 is very cheap in comparison to all other storage systems since it's a persistent file storage. It is supported by all the big data frameworks, Spark, Hive, Presto. So you can have any processing, use the S3 as a source system. You can do all the processing using S3 as a source. It decouples storage and compute. That was a principle which I discussed in a previous slide, that we have to decouple your storage and compute. If you would have same system where storage and compute would have been there, so you have to create a compute power also while creating a storage power. But since S3 has decoupled the storage and compute, so you don't have to run any compute cluster for storage. You just go to S3 and store your file. You don't have to create a compute cluster for storing the file. Second is that it can run, you can use S3 and use EMR cluster to run all the processing you required, whether it's Spark, Python, Hive, whatever language you want, you can easily do it. The third important, it is designed for 99.997 powers. That means you are totally assured that your data is not lost. It's always durable over there in S3. You don't have to pay extra for data application within a region. It's a secure, it's keep data even encryption at rest. And lastly, and most importantly, it's low cost. So storage is very cheap in comparison to any other storage when it comes to Amazon S3. So like in this mention, in media file, log file, we can use S3 as a storage. Now comes what should we use when we have data structure, transaction, or database record. So there we have three options. One is in-memory data storage, second is NoSQL, and third is SQL. So in-memory, we can use Elastic Cache, we can use Amazon DynamoDB Accelerator DAX. For NoSQL, we can use Amazon DynamoDB, and for SQL database, we can use Amazon RDS. So like in RDS, it's like managed relationship database service. You don't have to install the software. You don't have to install the database. You can go to Amazon RDS, start using the database. You can create your tables, insert your data, and then use it. DynamoDB is a NoSQL database service, and Elastic Cache and DAX is for in-memory service, because many a time we need system where we require data in memory so that the output is processed fastly. Hence, we use in-memory database system like Elastic Cache, DynamoDB accelerators. Now, how we can evaluate which is best for our application? Whether we should, like for example, we know that we will get data into transaction record like row and columns. So should we use Elastic Cache? Should we use DynamoDB, or should we use RDS? So how we can evaluate it, or how we can identify it? So that we can identify what's the structure of data which we are getting from the source side or the collection application. Is it the fixed schema? We know that there are only 10 columns will be there and 100 record will be there, like 10 column name, place, date of birth, age, gender, salary, department. So if we know that the schema is fixed, then we can choose wisely. But if we know that schema is not fixed, schema could be in JSON format. In JSON format, it can have multiple values. For one record, it can have 10 values. For second record, it can have 20 values. Or it is key value pair, like for every key, there's one value. So it's one-to-one relationship. So we have to identify what's the data structure being coming from the incoming data pair. The second is access pattern. how you want to access that data. For example, you have the data in the same format which is in the other company, but how that stored data is used in your third application or your downstream application makes it more important to evaluate which data storage to be used. Then again, data characteristic. You want your data is hot data, warm data, cold data. And fourth is the cost. Cost is always a factor. Maybe your data is very cold, so you don't have to use a very high cost database storage, because you know that it won't be accessed very frequently. So let's store into a device which is less costly but can keep a good amount of data. So this is the result for it. If we know that the answer, that a structure will be fixed schema, there will be only 10 records for all the records which are coming, 10 column: name, age, gender, place, salary, department. We know that there will be only 10 column every time. So go for SQL database, or maybe no SQL database. SQL database means RDBMS, relational database, like Oracle, or you can have MySQL server or SQL server, anything. When you know that schema is not available, schema is not free, it is free. It's like a JSON format. So you have to go for no SQL. In that particular scenario, SQL database won't work because you don't have a you don't have a fixed schema. You can either go for search database, or you can go for no SQL database. When you know that you have a key value pair, that always a record coming from incoming system will be in a key value. Then you can have an in memory also, like Elastic Cache or Redis, or maybe you can give a NoSQL like DynamoDB. There is fourth type of data value which is coming in very frequent currently now. This is graph database, relationship between node and root. Like A is linked to B is linked to C. So that is graph data. If you know that graph data is coming, then you can use graph database. Similarly, if you go by the access pattern, you know that the data what I will be store, it will be used in a simple way, like key value pair. In user will pass an input as a key, you will get the value. So we know that the access pattern is like key value. So in memory and NoSQL is the best one to be used. Reason being, NoSQL like DynamoDB works on key value pair only. So for every key there will be value. So it will be very easy to access and the speed will be increased. When we know that simple relationship is there in data which will be accessed by the third party, third team, or maybe downstream team, like one to n, maybe m to n, then NoSQL database is good. But when we know that this data will be used by teams that will join multi-table, do Windows query, do correlated query, do sub query, and do a complex query, then SQL database is good, because that will give like indexing will be there, partitioning will be there. So that will give the access power to a huge number. When we go for in-memory or key value pair like database, that won't be able to do multi-table joins very easily. They will take time, but SQL database like Oracle, MySQL, RDS, they will give a result in a faster performance way. Fourth pattern is like search pattern. Like you have all opened the e-commerce application, whenever or the left or the right you have a search button, you can just type mobile category or the mobiles available, so it will give result within 1 millisecond. So there we have to use search database, because we don't have to wait for joins to be available or joins to be applied, then only data will be there. So in that case, search database are the fastest one to be used. But when we know that the resulting team will use this data in a graph traversal, like which node is linked to which node, in that case, we should always store our data into graph DB. So hence, data structure of the incoming data and the access pattern of output data is very important while evaluating which technology to be used. So in SQL database will be used for fixed schema. Graph DB will be used for graph schema whenever we have graph for data coming in system. Similarly, when we have multi-table joins as output, data is expected by analyst, so we will use SQL database for storage. But if we have search as a access pattern, then we will do search database. So this is a complete picture of the storage when it comes to the transaction system. We have in-memory database like Elastic Cache, Redis, Amazon DynamoDB Accelerator. For Graph DB, we will have Janus, Neo4j, Apache Tinkerpop. For NoSQL, we have DynamoDB, HBase, MongoDB, Cassandra. For SQL database, we have RDS, we have MySQL, Postgres, SQL Server, Oracle. Similarly, for search database, we have Elasticsearch and Cloud Search. So as per our requirement, as per our analysis, we have to identify which database or which database tier effectively search our option, and then we can choose one of them. Now, in this previous slide, we know that we have already studied about the transactional data, what we can use. Amazon S3, we have finalized for file system. Now comes the streaming data. When we know that we have in streaming data coming from our source system, then what all options are available in AWS, which we can use for our streaming storage. So we have Amazon Kinesis Stream, we have Amazon Kinesis Firehose, we have Apache Kafka, which is an open source. We have Amazon SQS, we have Amazon SQS FIFO standard. So these are the this is a complete picture of all the 5 different product available for streaming, messaging, storage. And as per our requirement, we can choose it. For example, if we have the manpower, if we have the budget, and we know that we can handle the configuration and manageable of particular stream, then we should go for Apache Kafka. Reason being, Apache Kafka is open source. But we need people to manage it. It is not managed by cloud, but Kinesis is managed by cloud. Kinesis Firehose is managed by cloud. SQS is managed by cloud. So, but if we don't want to take that particular responsibility on our overhead, then we can go for Kinesis system. But if we know that we can manage that particular entity, we should go for Kafka. Now, just see the data retention period. In Amazon Kinesis, it's 7 days. In Kafka, it's configurable. So, for example, if you know that I have to keep my data for at least 15 days, 20 days, then you might not go for Kinesis. Reason being, it only keeps data for 7 days, the incoming messages. Whereas Kafka, you can configure to 15 days, 20 days as per your requirement. Similarly, parallel consumption is available in Kinesis, in Kafka also. Cost wise, both are same. The only extra cost in Kafka is that you have to do the admin work also, like upgradation, creation, cluster creation, keeping the housekeeping, zookeeper, everything you have to do yourself. Reason being, it is not managed by cloud, so you have to put extra cost, extra people, extra money over there. But in terms of Kinesis, it's low cost. Reason being, everything is managed by cloud, Amazon. You have to just write your application. Similarly, if you talk about the parallel consumption, it's available both in Kinesis, it's both available in Kafka. So row object size, its limit is 1 MB in Kinesis, but in Kafka, it's configurable. You can even more increase it. So these are all the parameters which you have to evaluate before selecting which tool to select for stream messaging. All tools serve your purpose. It's just that their purpose is different. What I am doing is maybe different from what A is doing it for will be different from what B is doing it. So all the tools and technology will serve the purpose if you know what your purpose is. Like if you know that your retention period is only 5 days or 3 days, so you don't have to go for Kafka, invest extra people and money for doing admin property. You can go for Kinesis stream. You know that it will be managed by AWS. All the infrastructure service will be done by AWS. So why to go for extra head overhead on your head? Like you will maintain all the properties, or you will do all the admin work of the creating cluster, keeping it upgraded, keeping it with the latest version sync. So go for Kinesis. But if you know that you have to retain the data for more than 15 days, more than 10 days, 20 days, so in that case, you have to go for Kafka, because Kinesis will only give the 7 days retention period. In that case, you have to bear the cost of admin rights also. So this is in totality what all the data store we studied, whether it's for transaction system like Graph, SQL, Search, or like S3, Amazon Glacier, in memory. So all is there. Like if you require the hot data, you have to go for NoSQL, in memory, Graph, or maybe Search also. But if you want a cold data, Amazon Glacier is the best. S3 is good. You can keep all the data there. Access rate will be reduced. Reason being, it's a cold storage. Whereas for in memory, NoSQL, Graph, the access rate will be very high. Reason being, they are meant for it. But still, since they are very high rate accessible, so their cost will be more. So if you can see in the cost per GB, in-memory Graph is more in comparison to S3 and Glacier. Similarly, latency is very low in for NoSQL in-memory Graph, because their cost is very high, their request rate is very high, so their latency is very reduced. Similarly, data volume accessible in terms of S3 and Glacier is very high, because in Glacier or S3 you have petabyte of storage, whereas in-memory or Graph or NoSQL you will have very gigabyte of storage will be there, because you will only access only keep those data that is important for you, so that the latency is reduced for accessing. So this gives a complete picture what all parameter you have to see, what all services are available, and which service you have to choose. Similar, like for example, you know that you have to reduce the cost, but you want to increase the latency, reduce the latency also. Then search or SQL database is good, because in memory is very costly. But you can compromise with the latency, but not with the cost. Then you have to go for S3. So these all parameters you have to think about, like cost will be cost, request rate, latency, data volume, what's the structure of your data. And on that basis, you can define, okay, this is what I'm looking for. So if we talk about the total summary of this particular application, like data storage, like which data store should I use? Elastic Cache, Dex, DynamoDB, RDS, Elasticsearch, S3, and Glacier. So this gives a total analysis of all the system: latency, data volume, item size, request rate, storage cost per month, durability, availability. This picture is right in front of you. Now, you as an engineer or as a developer, you have to decide which storage is good for me. In fact, not good, but best for me. If you are okay to compromise the latency, you can reduce the cost. But if you are not okay to compromise the latency, you have to bear the cost for it. Similarly, durability. If you know that my data, I don't want it durable, I can handle it. Even if it's available for 7 days, I can handle it. Then go for Elastic Cache or DAX because durability is very low. But if you know, no, latency is something that which I have to follow in any case. Latency should be reduced, should be minimized as possible. Then you have to really go for Elastic Cache, DynamoDB, DAX because they give you result in milliseconds. So everything depend upon your use case, your organization need, how you have to choose your data store. All the data store will work efficiently if you use as per their purpose. Just imagine for data warehouse, you are using Elastic Cache. No use. It's a complete mismatch. Similarly, for transaction system, you are using S3. Totally mismatch because the latency will be so high for S3 that your front end customer will be very bad for experience for them. Like, okay, for in 5 to 10 seconds, I'm getting the result for mobile category. Just imagine it as an end user if you're using it. So your purpose should drive which technology should I use instead of the technology driving use this because it's costly or it's very cheaper. So this is a very small activity for everyone. Like this is a real time example. So there's one question this I've copied from AWS developer sites. So one of the customer asked to Amazon that I'm currently scoping out a project. The design call for many small files per up to billion during peak. The total size would be around 1.5 TB per month. So should I use Amazon S3 or Amazon DynamoDB? Since everyone see the size is 1.5 TB per month and Amazon S3 is very cheap. So your first preference would be to use Amazon S3 because it's very cheap, and let's go for Amazon S3 instead of DynamoDB. So when the team did the real calculation of what would be the amount to incur for this particular application, so there is a very good application created on AWS site, simple monthly calculator. So you just select the services. Like on the left side we have DynamoDB, on the right side we have S3. You mentioned the item size as 2 KB, request read is 300 per second, and total size is 1.5 TB, that is 1483 GB, and the request object per month is this. So when the cost of this particular application was derived, everyone is astonished. S3 was more costlier than DynamoDB, even when the storage is very low. If you see, Amazon S3 storage is only $34, whereas for DynamoDB the storage is $383. But the put and the list request is 3,888. That makes whole S3 as more costlier than DynamoDB. So storage is very cheap in S3, but the number of write you are doing on S3 makes it more costly in comparison to DynamoDB. So for this particular scenario, DynamoDB is much cheaper and much effective than S3. Let tweak, just do a little tweak of this question. Now we have same requirement, but the object size is 32,768 bytes, 32 KB. Now in that case, when the size of the file increases, S3 becomes more cheaper than DynamoDB. In S3, the storage cost increased to 545, but the put list request remains the same. Reason being, number of hits on the S3 will be the same. It's just the size of file has increased, so the total cost is 4,000 only. But for DynamoDB, throughput also increases cost and storage cost also increases. So just see, same application, same requirement, only the difference was the size of the object. If the size of the object was 2 KB, DynamoDB was performing better. But when the size of the object increased to 32 KB, 32,000 KB, the Amazon S3 start giving more cheaper result than comparison to DynamoDB. So hence, it's very important to analyze your situation, analyze your use case, whether we should use X service or Y service, or which is better in which scenario. Maybe today's requirement is like your object size will never breach 2 KB limit. So in that case, DynamoDB is good. But if you know that in future it can go for 32 KB, 32,000 KB also, then in that case you should always go for Amazon S3. So this is just a very small example, real-time example, where if we start evaluating our technology very efficiently, then we can definitely bring up the solution which not only serve our purpose but also be a minimalistic in terms of cost. Now the second part of it, that we have the storage. We have decided the storage. We will use this storage. Now, do we have something for ETL in AWS? Yes, the answer is yes. We have all the vendor products like Alteryx, SnapLogic, Talend, Informatica, Aluma, Matillion. But AWS itself also has a managed serverless ETL service, that is Glue. So again, this is serverless. You don't have to do anything. You just have to go to Glue, start writing your code in Python, Scala, and do the transformation, do the load. So it again serverless ETL. You don't have to bother about the cluster. You don't have to bother about the backend server, whether how to analyze it or how to handle it. Everything will be done by AWS. You have to just start using Glue. But if you want to use third-party ETL tools like Informatica, Talent, so that are also available. Now comes the fourth part, that is the analyze part. Because in today's world, everything depends on analytics. We should have tools and services which can do interactive, batch, real-time, predictive, all types of analytics. So when it comes to interactive and batch analytics, the tools available in AWS are Amazon ES, that is Elasticsearch. The second tool is Amazon Redshift and Amazon Redshift Spectrum. In Redshift, it's nothing but a managed data warehouse. So you will have the parallel processing. You will have all the facilities available there. So you can efficiently create a data warehouse using Amazon Redshift. Redshift Spectrum is even one step ahead. You don't have to create even a schema for in Redshift. You have to create tables. You have to create logic to insert those data into tables. But in Redshift Spectrum, you can directly query your S3 data. You don't have to create table. Data is there in S3. You just start writing your queries over the S3. So that is a very good example. Like for example, for maybe some team don't have the bandwidth to create tables, or they don't want to create tables and have overhead of maintaining them. They can go for Redshift Spectrum, where they can directly start using S3 data by directly querying them. Another service available is Amazon Athena. It's the same like serverless application query services. You don't have to do anything. Data is available in S3. You can start querying using Athena. It's a serverless again. Then the fourth service available for analytics is EMR, Elastic Map Reduce. So it provides frame capability and framework for all the services, open like Apache Spark, Flink, Presto, Hive, Pig, Tej, HBase, anything. So it's Elastic Map Reduce. You don't have to worry about all the cluster management, cluster creation. You have to just write your code over there, run your application, get the data in the format you want. So these are the services available in Amazon for interactive and batch analytics. The second is predictive analytics. Nowadays, everyone is focused on giving prediction about their data, using their data so that their policy could be driven on that base. So for that, we have Amazon AI, which is API-driven services. So you don't have to bother about writing code for creating cluster, creating model. It's already there. Amazon Lex is used for speech recognition. Poly is used for text to image. Recognition is used for image analysis. For example, you have number of image, you have to create a model over it. So you can use Amazon AI for predictive analytics. Similarly, for managed machine learning platform, you have Amazon ML, Amazon Apache Spark ML on EMR. So everything is available. You have to just write your code over there. You don't have to bother about creating server, creating cluster, managing them, upgrading them, maintaining the serverless things, or investing a single manpower on infrastructure related services. The latest one is AWS Deep Learning AMI, Amazon Machine Images, where it is already installed with all these models like TensorFlow, Cafe, Torch, Cognitive Toolkit, and other DL tools and drivers. So everything is inbuilt. You have to just start using it as per your requirement. Another type of analytics which everyone is focused on real-time analytics. Like we have batch and interactive, then we have predictive analytics, and now we have real-time analytics. Like data is coming in the real-time, the stream format, how we can analyze it. For that, we have Spark streaming available on EMR. We can open the Amazon EMR, switch on the cluster, and just start writing out the code over there for real-time analytics. We have Kinesis analytics, like for streaming storage, we have Kinesis storage for storing the data. Similarly, for analytics, we have Kinesis Analytics. It's a managed service for running SQL on streaming data. Just imagine you have a streaming data and you are writing SQL over it. You are using all your correlated queries, window function on the streaming data. So that gives you more power to understand the data. So you don't have to wait for batch processing to complete the data load and then you can run your SQL. In fact, on your running data, on a streaming data, you can run the SQL. So that will give the more insights. Okay, for current month, for current period, like for example, 1 minute, 2 minutes, there's a huge spike in the number of ordering of particular category. So that means that this particular order is particular category of product is in huge demand. So why not increase the input of that particular category? Similarly, Amazon KCL is a Kinesis client libraries. It are all different libraries available for stream and real-time analytics. And the last one is AWS Lambda. So Lambda is a serverless application. So you can treat as a function as a service for Lambda. You can choose any language you want. It support multiple language, around 15 16 language, where you can write your code. You can use S3 to publish the events Lambda, or you can even use Lambda to get event from Kinesis. So in terms of analysis, analyze or process step, we have real-time analytics services available. We have predictive analytics service available. We have interactive and batch analytics services available. So when we sum up all these services which we discussed, so this gives a complete stack of us. For collection, we have web application. We can create web application. We can create mobile application. For logging, we can have CloudWatch. For similarly, for IoT, we can have IoT platform, dense device sensors, which can collect the data. Once data is available, now we have to choose the storage. So which storage which we'll choose? If the data incoming is in the form of records transaction, we can go for cache, we can go for NoSQL, we can go for SQL. Again, within the three, we have different types of parameters, like we want to have latency, or we want to have cost, or how we access our data. So we have to identify on that particular basis. For file system, Amazon S3 is the best option. Storage is very cheap. You can keep on putting your files over there. For streaming, we have different types, like we have Kafka there, we have Kinesis Stream there, we have Kinesis Firehouse. Again, we all have discussed about what all facilities this Kafka brings, what all overhead Kafka had, what all good point Kinesis brings, how Kafka is better than Kinesis, or how Kinesis is better than Kafka. So we have done the comparative analysis. Through that, we can identify which storage system we should use. Then for ETL, number of vendors products are available, plus AWS Glue, which is a serverless ETL, so we can use that also. Now coming to process and analysis step, there we have studied about predictive tools available, like Amazon AI for recognition, Lex policy, or maybe Amazon DL, any tool we can use for prediction. For interactive and batch, we can use EMR, Elasticsearch, Redshift, Spectrum, Athena. For stream, again, we can use Spark streaming, we can use Kinesis Analytics, we can use Lambda, we can use KCL. So depending upon our use case, depending on what we required and what our design pattern, data pattern, access pattern, cost, durability. So all these things has to be taken into consideration. Then we can select our particular tools. So now comes the consume part. I haven't done a detailed in edit slide for consume, because consumes are very generic one. Like for analysis and visualization, you can use tools like Tableau, QuickSight, Looker, MicroStrategy, Click. Similarly, for data science, you can use Jupyter Notebook, you can use Anaconda, you can just write your Python code over there, or R Studio for writing code in R, and you can start creating your data model, deploy your data model, train your data model to give you result. So the on the consume part, the upper side is for maybe for data science people who are more focused on data science, whereas for an BI people who are more focused on reporting and analytics, they can use any visualization tool like QuickSight, which is Amazon inbuilt tool, or Tableau, which is vendor party, third party, Looker, MicroStrategy, Click. So these are all the tools available for consume step of the big data processing. So in complete stack, if we talk about, we can choose whatever is required for the collection, store, ETL, process, analyze, and consume. As per our requirement, we can choose it. So this is a complete picture of all the services available as far as big data is concerned in AWS. So just to summarize, just to add few more things into this complete stack, is that AWS also have data catalog and security governance services, which is inbuilt in nature. So you don't have to focus more about that. Like for example, IAM rules, so that you can limit the use of your data only people who have authorized access can use that data. Then CloudWatch can be used for governance. Okay, for all the output will be shifted to CloudWatch for analysts. Okay, this job took 10 minutes today, but tomorrow it's taking 13 minutes, and day after tomorrow it is taking 20 minutes. So there's a huge spike in the runtime of the job. So we can create the logic over there, like, okay, if the runtime of the job increased to 20 minutes, then please send us a notification or send us an email. Similarly, CloudTrail. So all these are data security and governance application services available, which we can club with the big data technology, big data processing services, and it will give a complete architecture for us. If we choose services like this, and if we have data catalog and security and governance with us, then we can easily create a big data platform, big data architecture for our organization that will be robust, scalable, security error free. There will be no unauthorized access, and through visualization tool or maybe data science model, we can generate values that would enhance our business, and our company will become a proper data driven organization. So the major reference I have used for creating this session is like AWS reInvent Summit. So it happens every year. So they have multiple topics. So if you like, you can on YouTube also you can see for AWS reInvent Summit. So they tell about each and every services, whatever new they have produced and how they works, and how you can use those services for the betterment of your data processing architecture. And the third is that the docs.aws.amazon.com. So this particular site has documentation for each and every services available in a very detailed and minute level, so that even if you are no voice of cloud user, you can easily understand how cloud works or how this particular service works. I think we can open up for Q&A. So if you have any question, do let me know. We can quickly jump onto those. So I have a few questions over in Q&A section. So first question is like, how does our AWS architecture changes when an goes from a startup to bigger org? It does not change drastically. It's just that you increase the scalability of your system. For example, when you are a small org, you have 10 cluster Hadoop, but when you go to bigger org, you can have to 100, 116 cluster of whatever it could be. Similarly, the DynamoDB or the database which you are using, it currently it could have working on 4 host node, but if you go to a bigger organization, it will work on 16 host node. So these are all things that happens drastically. They won't be changed. Only you have to scale a system, and that's why cloud is very efficient, because in cloud you don't have to worry about the scale, horizontal as well as vertical. You can do anytime. You don't have to focus on creating more structure. Just remember, without cloud, you have to do everything. So you are working for company A, and company A decided to increase the cluster from 16 to 32. Then you have to work with the data center team who will increase the cluster. Then you have to again work with the database team who will do the analysis and the impact analysis of that. So it will take around 3 to 6 months of this particular project from changing host nodes from 16 to 32. But when it comes to cloud, within a single click, you can increase your cluster size from 16 to 32. So you will save those 6 month time if you're not working on cloud. But if you are working on cloud technologies, all these scalability issue will be vanished in one click only. So second question is, what if our data is not within specified schema, but also we need to join our data to put result on BI? What to choose here for storage? See, when you know that the schema is not specified, so you cannot choose RDS. You have to go for DynamoDB only. And using DynamoDB, you can use data to join your data in your maybe BI or lookup or looker or tableau, whatever you are using. But in RDS, you have to specify the schema. One case could be like you have 10 columns. Maybe for some record only 8 are coming from the source side. So in the query, in the insertion, you can write the exception that whenever this particular column is not coming from source, you can enter 0 or null. But this is very limited solution. Like for 10 column you can work, but just imagine you have 2000 columns in a table, and 1500 are coming null as from the source side. So in that case, you cannot write a SQL. That is very monotonous and also not very effective. You are writing insert into table where all the records are null, just enter 0. So if you're not having a specified schema, go for DynamoDB, not for the RDS. When will we use SageMaker? SageMaker is again data science project. So once you have data, we have stored the data, then you can use SageMaker for all the application. It's just that I haven't include SageMaker over here, but SageMaker can be used for consumer part of that step. Who the real-time analysis work will we will manually analyze the data, or some tool automatically visualize the insight? No, what you can do is that you have a dashboard inbuilt for you. As soon as data arrives, it will get populated into the dashboard. You don't have to do manual insertion again for the dashboard to show data. You have to create a streaming analytics like using Kinesis or Kafka, so that all the data which is coming from source get inserted into the storage in the real time. Similarly, for Kinesis analytics to work, whatever data is coming in the store, it will definitely go into the real time into the dashboard. So you don't have to manually analyze the data every time, or Kinesis analytics available. You can do all the things automatically visualization. So any other question? Because I can see only 4 question in quiz. Also, for example, if you have some question, you can ping me or you can chime in on the LinkedIn profile of mine. I will be very ready to help you out there also. No issue in that. Thanks a lot everyone for joining the session.